Hello students, this is Dr. Church. We're going to take a quick look today at the factors affecting climate. There are 6 factors affecting climate that we want to take a look at, and so let's just jump right in. Factors that affect climate. Identify how 6 key factors affect local climate. Well, what are those factors? They are latitude, elevation, topography, water bodies, atmospheric circulation, and vegetation. So those seem pretty common sense things to look at. We've looked at several of these things in the past, and so let's just take a look at each of those in turn. So the first factor that affects climate is latitude. Now, if you remember, latitude is the location on the Earth that is basically moving from the equator up to the poles, or up towards the North Pole or down towards the South Pole. And so how does latitude affect climate? Well, as we know, the Earth is tilted on its axis, and so the angle at which the sun's rays hit the Earth varies as we move away from the equator. If we look here at the sun's rays, we see that the sun's rays here are coming at the equator at the most direct angle, and so they're going to be much brighter at the equator. As we move up towards the poles, we see that the angle here is going to decrease. So as the angle of the sun's rays decreases, the intensity of the sun's rays decrease. Therefore, that's going to feel colder as we move up. So we've talked about that when we looked at weather, and that's something that you should be fairly familiar with at this point. So the latitude summaries are given here. You've got 3 zones: the tropical zone, the temperate zones, and then the polar zones. Obviously, the tropical zones are the hot and moist zones. The temperate zones are more moderate temperatures. We live in a temperate zone. And then, of course, the polar zones are much colder. You see that the angles that are given there, if we go back and look at the previous slide, we can see that at 0 degree at the equator, the tropics are going to go from 0 to 23.5. The temperate zones from 23.5 to 65. And then here again, you can see that we're kind of in the middle of that that temperate zone, which is, we're right there. Okay, so those are listed for you. What about elevation? Obviously, as we go up in elevation, the temperature goes down, and we've experienced that. If you've driven up to the mountains, you can often just feel that the air there is cooler. So as we go up, which is kind of counterintuitive, sometimes you think, well, golly, I'm getting closer to the sun. Isn't it going to get warmer? But in fact, it doesn't, because there's a moderating temperature moderation from the surface of the Earth, and just the way that that holds heat. As you go up, the temperature tends to go down, so it's going to be colder at higher elevations. Just by way of an example, here are 2 cities. We've got 2 cities that are Phoenix and Flagstaff in Arizona. Here's a temperature versus and precipitation chart for each of the months of the year, and you can see that in red is Phoenix, which is much warmer. Phoenix elevation is 338 meters. Flagstaff is much colder, and it's at 2,134 meters. And even though those 2 cities are located, quite near one another here, okay, their elevations are different. And so we can see just an example of how elevation works. The other factor, third factor, is topography. Topography is just the lay of the land, the nature of the shape of the Earth there. Topographic features like mountains will affect the climate of that area. Remember, we've studied the windward side. That's the prevailing winds are blowing on that side. The leeward side is the other side where the wind is not going to be blowing so directly against that area. And you'll see that the windward side tends to be cool and wet. The leeward side tends to be warm and dry. Probably my favorite example is Hawaii. You've got the westerlies that blow across Hawaii, and on one side it tends to be a bit warm and wet, and on the other side it tends to be dry. And of course, you know, my favorite artist who sang, Elvis Presley. And blue Hawaii. The greatest singer of all time, Elvis. I knew I had to be. Yes, thank you, Elvis, for that little musical interlude. Okay, factors that affect climate, water bodies, large bodies of water. We've studied this in the lab. We know that the earth warms up and cools down much quicker. The water warms up and cools down much slower, so it tends, again, to be a kind of a moderating factor there. Large bodies of water, such as lakes, and of course the ocean, tend to moderate climate. And we have atmospheric circulation, the global winds. We've looked at these in some detail again when we studied the weather. Global winds affect climates just because of the way they distribute heat. In the United States, our global winds, the westerlies tend to move from west to east across. And again, because of the circulation of the earth, that Coriolis effect, which we've looked at in the past, and just the prevailing winds, the uneven heating of the earth, and the fact that the earth is rotating will tend to let those winds blow in a consistent direction, and that will affect the climate. The polar cells, again, this cold air near the poles will drop, the warm air rises, and then that sets up a circulation pattern with the mid-latitude cells and then the Hadley cells. Again, these are just weather factors that tend to affect the overall climate for an area. And then finally, it's just vegetation. If you've ever walked into a forest in the summertime, you can feel the temperature difference. The vegetation tends to, again, to affect that temperature. The transpiration of the trees with the movement of moisture will tend to affect that. And so this kind of summarizes the factors that affect climate. So you probably just need to be familiar with those. That would be something you could identify on a quiz or exam. And they're pretty straightforward. Be familiar with how they work, and you should be good to go.